Good morning, everyone. It is Thursday, April the 2nd, and here are the headlines for today. Well, guys, we've been looking at a severe weather threat up in the Northeast starting on Tuesday. That threat shifted to the southwest over Texas and Oklahoma during Wednesday, and then back further north and east over the Midwest as we got into Thursday. So, we're going to be talking about this extended severe weather threat as we go into the weekend. Guys, I want to start us off by looking at the thunderstorms that blew up over Texas and Oklahoma during the day Wednesday. Again, we saw a lot of severe thunderstorms with straight line winds and large hail, but then also we saw a few isolated tornadoes, right, going into Wednesday evening. Now, this threat's going to shift further to the north and east over places such as Missouri and Illinois as we get into Thursday afternoon. Now, we'll likely see these thunderstorms over Missouri and Illinois continue into Thursday evening, and we should see this wrap up maybe around the 8 or 9 p.m. time frame. Also, take note of the snowfall here on the northern side of the system. Again, it looks like we have a wintry mix even involved in places like the UP of Michigan, so that's going to really cut down on the snowfall totals up here. But it really could lead to some messy travel for you guys Thursday night into Friday morning. Also, take a look at this approaching trough coming in during the day Thursday. This will be dropping those temperatures in the northwest, right? But also giving us a good chance of rain in places like Seattle and Portland. And we're talking about maybe a quarter inch of rain in most places here. But mountain snowfall of maybe 4 to 8 inches in some of these mountain passes in Washington State and Oregon State. We can see how powerful this trough is here, at least initially, when it moves into the northwest. When you see the deeper blues here on the map, this is indicative of really low heights in the middle troposphere. Now, this kind of breaks down as it gets into the northern Great Plains here, but it's still holding together. And this will provide energy for severe thunderstorms through the weekend as this pushes into the northern Great Plains. Now, what's even more impressive is just broadly speaking, how there's ridging um, over much of the US here. So, if we look at, let's say, the day Saturday, we see mostly red on the map here for the US. And in particular, take note of the Northeast and Mid Atlantic. That's where we find the deepest rids here the next couple of days. And this is again just showing us how that warmer air is going to be moving into the mid Atlantic and Northeast. And we're going to be talking about 70s in upstate New York, reaching into southern portions of Maine, possibly, as we get into the weekend. Now, this is the temperature anomaly map here, and we can see where we have blue. This is the below average temperatures. And we even see some purples here, right, over the northern Great Plains, perhaps getting into Minnesota and Wisconsin here. Now, this is just in time for that snowfall, but also take note here of the deep rids, right, over much of the east here. And again, that's showing us those temperatures in the 80s in the southeast and then also the 70s getting into the northeast. Now, as it goes for April standards here, this is pretty warm weather for the mid Atlantic, the Midwest, and the Northeast here that we're seeing across the U.S. However, we'll see a cold front pushing through in late this weekend, and that will help to cool down the temperatures back in the Northeast below the 60s and 70s that we're seeing this weekend. You notice that shows 67 here in upstate New York. Again, this is around 1,000 to 1,500 feet here. So if you get down into, let's say, the capital district around Albany, expect temperatures in the 70s over the weekend. And further south, as you approach, let's say, Washington, D.C., on down to the state of Florida, we're going to see a lot of 80s here across the mid Atlantic and the southeast as we get into the weekend. Again, overall, when you're not getting rainfall and thunderstorm activity, we'll be experiencing some very warm weather, right? Definitely spring-like and even summer-like in some locations. Well, guys, the last thing I want to show you here is this temperature gradient, right? Going from the Midwest into the Ohio Valley, back into the Mid-Atlantic. And we're seeing a temperature change of maybe 30 degrees here in some cases. And where we have that set up, right, we're going to have severe weather taking place. So, a rather large area here as we get into Saturday afternoon from Texas up through the Ohio Valley could be experiencing severe thunderstorms once again. Now, as of recording this video, during the day Wednesday, we saw severe weather over Texas and Oklahoma. And we can see where the Storm Prediction Center has indicated an enhanced risk for Thursday over the states of Illinois, Iowa, and even southern Wisconsin. But then we look ahead to Saturday, and we can see this redevelopment of severe weather over Oklahoma, Kansas, Missouri, back again into Iowa. So some of these places will experience multiple days of severe weather here across the country. And I can imagine this line shifting off to the east, right, as we approach the day Saturday and then even on Sunday. We'll see the green and yellow probably shift to the east. And I wouldn't be surprised again if you live in Louisville, Kentucky, Columbus, Ohio, maybe even Pittsburgh, Pennsylvania, down to Roanoke, Virginia. Again, these places here, even further south into Atlanta, Georgia, we could see some severe thunderstorms later this weekend as that cold front approaches the East Coast. With it being severe weather season here, so again, the months of April, May, and June, we need to talk about what soundings can show us here in terms of predicting the severe weather activity. So, one of the more important things that is helpful to meteorologists when they're predicting severe weather are these potential soundings that we can take a look at within our weather models. Now, there's two important axes I need to point out to you to have an understanding of this radio sound data. I want to point your attention to the left-hand side first. Highlight that for you and circle that for you here on this figure. Now, what I've circled here is the height in the atmosphere. So the next thing I want to highlight for you guys is the x-axis here along the bottom of the chart. Now, this highlights the temperature from -40 to +50 in terms of degrees Celsius. Again, this more or less tells you how the temperature changes as you move up in the atmosphere. So I want to break down three different lines for you guys to have an understanding of what's being measured in the atmosphere. And when this radio sound rises up, one of the things it measures is the moisture in the atmosphere. Now, the first line I want to show you guys is this green line furthest to the left, and that's indicating the dew point in the atmosphere as this device rises from the surface. The dew point is more or less a measure of the moisture content in the air. Okay, guys, so the next line I want to share with you is this red line, just to the right of the green line, and that's indicating the air temperature as the device rises up from the surface. Now, guys, the last line I want to share with you is that white dashed line off to the right. And what that's showing you is the saturated air parcel path. And what this really is showing you is how that cools in comparison to the air around it. So if you look at the red line, for instance, that's the temperature of the air around it as that parcel rises up from the surface. And notice that its path is a little bit to the right of the red line. And that's very important because that means that the saturated air parcel would actually be cooling slower than the air around it. And a warmer parcel of air is buoyant relative to the air around it. Now, guys, in this next image here, I've indicated a new term, right? CAPE. And that's showing us the convective available potential energy that's available to these thunderstorms that will be forming the next several days. Now, just to highlight for you guys, this is the CAPE here that's highlighted in red. And what that's really showing us is the separation between the dry air, marked by the red line, and the white dash line that I was showing you before, that parcel path, that saturated parcel from the surface, again, how that cools relative to the air around it. And the bigger the gap, the larger this red region is going to be in the figure. And when storm chasers look at a figure like this and they see a large gap between the two lines, that indicates to them there is a good potential of severe weather on this day. Now, that's just one factor, right? We call that again CAPE. The second factor that's just as important for these thunderstorms to get going is having something called a cap. So I'm going to highlight that for you guys here. Again, you'll notice this bulge right up to the right where we have the two labeled here. And one of the things that you can kind of look at here, if you were to start at the surface and work your way up in the atmosphere, is how the temperature cools. So let me do this real quick. I'm going to highlight this 75 degrees here along the x-axis. That's the temperature currently there, again, according to the sounding at this time. And as you move up, right, so again, I'm going to arrow up here. As that red line rises up, we're going to look for it either to move to the left, showing that it's cooling, or move to the right, showing that it's warming. And you'll notice initially here in this figure that it actually begins to cool, right? as it moves up the atmosphere. But then once it reaches about 850 millibars, this white line here, I'll show that for you guys here just off to the left. As it reaches that point in the atmosphere, notice what it does. It actually diverts to the right ever so slightly. And what that does more or less is puts a cap on the atmosphere. Now, if you want to see thunderstorms form, you want to see cooling from the surface all the way up the troposphere. And when you have warming that's in place in any part of it, that can work to hinder the development of these thunderstorms in the afternoon. However, when you have a small cap in place, like we're seeing here during the day Wednesday, again, this is kind of going into the storms that we're seeing over Texas and Oklahoma Wednesday afternoon and Wednesday evening. We saw this small cap in place in a lot of places. Now, if the temperature warms significantly here at the surface, which it could do beyond 75 degrees as you get later into the afternoon, it can perhaps break this cap. So, in other words, you might see the temperature be 80 degrees. And I'll highlight that here. I don't know if that'd be sufficient enough to break the cap in this instance, but what that could do is create a new red line. I'm using a white line here just to kind of show the difference in placement. But that would put that line further off to the right and perhaps break the cap that's above it. And if that were to happen, we'd see significant energy available to these storms, again, cooling all the way up the troposphere, which is what you want if you want to see severe weather. Now, even still, this is not everything that you need. You also need to have changing winds with height. I've got highlighted here the symbols at the bottom of this chart, and it's showing these flag-like features. And where you see the tick mark, again, the more tick marks on the flag, the faster the wind speed. And the area of the graph that's most important when it comes to tornadic activity is the first kilometer. So if you were to see a sounding like this, what you want to do is come over here and look at the 0 to 1 kilometer, just as reference here on the left. You kind of highlight that for yourself, and then you move back to the right and you look at the symbols. And if you see those changing a lot within the first kilometer, that might be a sign that severe weather could be taking place, especially later in the afternoon. And we can see here that it does indeed change direction. And what's harder to tell for you guys, and again, you just have to take my word for it, is that the symbol actually does add tick marks with height. So that's showing an increase of wind speed here from the surface to maybe 1 kilometer above. Again, for meteorologists, this would be around 850 millibars in the troposphere. Now, you might be interested, where does this actually take place typically? And the answer for that would be in the Great Plains, where we see this capping scenario take place. Now, what typically happens is that we might have some warm air over places like Denver, Colorado, and that's transported downstream into the Great Plains. You'll notice that this brown region here is a bit higher than the green region to the right. And that's showing us the elevations that you would see east of the Rockies in a place like Denver. Again, the elevations around the city of Denver are between 5,000 and 6,000 feet. I'm trying to show that here in the figure. Whereas out here in the Great Plains, that elevation might drop down to maybe 1,000 feet. And that's significant. And the thing about air masses with different densities is that they don't mix well. So if you have a dry air mass here in Colorado, and then you have a moist air mass in Oklahoma City, when those two air masses interact, you're going to see one over top of the other. Again, that dry air mass on top of the moist air mass. And that's going to help to create that capping feature that we see over the Great Plains. Now, this happens basically from North Dakota down to Texas, where we can see the scenario set up. And that's the reason they call this area Tornado Alley, because we see this a lot actually during the springtime. Now, this warming could take place between 850 and 900 millibars, like the example that I've given here. But notice here in this example, I've shown the temperature rising from 50 to 53 degrees. And then also, I've got the dew point here highlighted again in green. And I've got the temperature highlighted in red here. That's important. You'll notice that the air is not only warming up here at a certain level to 53 degrees, but in green, we're seeing the air actually dry out above as well. Again, that's just indicating that drier air moving off of the Rockies. However, this provides for a dangerous situation because moist air is less dense than dry air. And these parcels of air that do moisten at the surface can quickly move through that dry air in the troposphere and provide rapid development of thunderstorms as we get into the later afternoon hours like 3 and 4 p.m. Now, in this particular example, I'm showing 65 degrees at the surface here at 10 a.m. But as you can imagine, as you move into the afternoon hours with daytime heating, that temperature at the surface will go up. And when you have a front approaching from the west, what will typically happen is that not only this warm air builds up, but you might have moisture build up as well, right? Out ahead of that cold front. So you'll notice that in these soundings that not only the red line, but also the green line can shift off to the right as well during the day. So you might see this entire region here of red and green shift off to the right between the morning sounding and the afternoon sounding and align with this temperature that we're seeing above. Now, when it does that, we're going to see cooling all the way up the troposphere. And that means that cap is going to be removed, and we're going to have that fuel now available to these thunderstorms that are developing in the afternoon. Now, in the next slide here, I'm showing where the temperature could possibly warm by 10 degrees right in the afternoon. You'll notice that my green and red line have shifted off to the right, and they've now aligned with the temperature overhead, right? And what's going to happen is that where these two meet is going to be the lowest cloud level in the atmosphere. And as long as that is cooling all the way up the troposphere, nothing is going to work to cap these thunderstorms anymore. Now, when that moist air hits the dry air above it, what's going to happen is that it's going to cool much slower, right, than the air around it. And that's going to allow it to become buoyant again and rise quickly through these thunderstorm clouds that are developing and in a sense provide fuel more quickly, right, to those storms. Now, the thing about the capping feature is that it actually allows for the heat and moisture to build at the surface through the afternoon until suddenly around 3 or 4 p.m., the cap breaks. Now, when this happens, we have all this energy that's been building up from the morning hours into the afternoon hours being fed into the storms almost instantaneously. And that moist air, when it hits the dry air, it rises very quickly because of its buoyancy relative to the air around it. So, this more or less provides instant fuel to these storms developing over the Great Plains, and hence the supercell activity that we see in this location of the United States. Now, one thing I want to highlight for you guys is the significant tornado parameter. What you can do to see this same image is go to pivotalweather.com and it will show you all the high resolution models. Now, this is a particular HRR model run, and this is showing Texas into Oklahoma during Wednesday evening. And you can even see orange and red indices here. And this is indicating a 3 out of 10 potential here, maybe 30 to 40% chance of a tornado developing in this part of the United States. Now, what I typically look for is not only just one model, right, like the HRR showing this, but show similar areas, let's say in another high resolution model. And when I shift to the NAM, you'll notice that there is a shift to the left here in the potential of severe weather over Oklahoma in particular. Again, we're seeing maybe a higher chance, according to this model, for western Oklahoma. But I want to take this into account when I'm developing a forecast. One, that this area could be broader, right, than even what the Storm Prediction Center is showing. But then also the likelihood. If we're seeing this in two different areas here, according to two different models, we might see one area get it and another area not get it. And it's hard to tell who's going to get what. But I would say if you're seeing it across the board in all these high resolution models, there is a very good chance, right, of severe weather in that location. Guys, we're going to leave it at that today. I hope you enjoyed today's video. If you did, leave a like or subscribe. It really helps the channel. If you have any questions about what we talked about today, let's say in the radio sound data in particular and what the lines represent, just leave those in the comments down below. I should be able to get back to that in the next day or so. Until then, I hope you have a great weekend. Bye for now.